Hi guys, it's Mrs. T again. A review of how to do multi-mole problems. So that's where we're going to be doing. If you have your aim sheet handy and you can take that out. Some of these questions will be directly on the aim sheet. If you don't have it, you can certainly pause while you write down the questions on the screen and resume when you're ready to start working on it. So again, I'm Mrs. T, chemistry teacher at Calhoun High School in Merrick, New York. In case you don't know me, in case this is your first video. If you're one of my returning students, you're certainly welcome to come to Extra Help and ask me any questions, or certainly send me an email or respond to that any of the remind messages to get me a question. So the first thing that we need to know is that when we're talking about our multi-mole questions, one second. Yeah, there we go. We're talking about our multi-mole questions. Anytime you have a balanced equation, the coefficients are going to give us a mole ratio. So this absence of a coefficient just means that there should be a 1 there. So that means that nitrogen reacts with hydrogen in a 1 mole to 3 mole ratio. That's what the coefficients tell us. So for every 1 mole of nitrogen, we need 3 moles of hydrogen. So if we were to have 2 moles of nitrogen, we would need 6 moles of hydrogen, because this number here always has to be 3 times that number. So 3 to 1 is the same ratio as 6 to 2. As we are moving forward, this is one of the questions that was on the aim sheet. So if you want to just take a look at that and see which question we're working on right now. Again, remember this is an understood 1 right here, and it says how many moles of ammonia are produced when 9 moles of hydrogen react. So ammonia is NH3, so when it says how many moles of ammonia, we're going to put it in X over the NH3. And 9 moles of hydrogen means that on top of where we find just hydrogen in the balanced equation, we're going to write a 9. And that gives us our proportion that we're going to set up. So that means that 9 over 3 equals X over 2. We cross multiply and we get 18, right? 9 times 2 equals 3X. When we divide both sides by 3, our answer comes out to 6 moles, which makes sense because 3 to 2 is the same ratio as 9 to 6. And if we want to use the same balanced equation for another question, we're just going to cross out or erase the numbers up on top. And it says this time, how many moles of nitrogen are required to react with 6 moles of hydrogen? So since they asked us about just nitrogen this time, we're going to put an X over the nitrogen, and they told us 6 moles of hydrogen, so a 6 goes up on top there. And what I can see right away is that this number on top is twice the coefficient, which means that my X will be twice the coefficient for nitrogen. But in case you didn't see that, we can pull these down and set up a proportion. X over 1 equals 6 over 3. When we cross multiply, 3x equals 6. Dividing both sides out by what's in front of our x, we get that x equals 2 moles. So this is the general process for doing some multi-mole problems. I think I have one more set of examples here. Yep, I do. So again, any place that there's not a coefficient, we go in and we put a 1 because that's what's understood. So it says how many moles of oxygen, which means I need to put an X over where oxygen is by itself. Air will be produced when 18 moles of water react, which means I go and put an 18 on top of the water. So I can see that I multiplied this coefficient by 9, which means that my X is going to come out to 9. But if you don't see that, we can just pull this down as our proportion, 18 over 2 equals X over 1. When I cross multiply, I get 2x equals 18. Oops. And then we're going to divide both sides by what's in front of our x. And my answer comes out to 9 moles. And then there's another problem for the same balanced equation. So I'm just going to erase my numbers up on top. You could certainly just put a line through it. I just want to keep this neat for the video. So it says how many moles of hydrogen, which means I put an X over where hydrogen is all by itself, will be produced when 8 moles of oxygen are produced, which means I put an 8 up on top of where oxygen is by itself. And just remember that if it says how many moles, if this many moles, that's when we start to do this process. So I see that I multiplied oxygen's coefficient by 8, which means that hydrogen's coefficient will also need to be multiplied by 8, and my answer is going to come out to 16. But in case you don't see that and you want to just use the process, word problem, numbers of moles go on top of the coefficients, and we set up a proportion. X over 2 equals 8 over 1. And when I cross multiply, I get X equals 16, which again, remember, is a number of moles. So hopefully this was helpful in solving mole-to-mole problems. This is Mrs. T. Please email me or come to Extra Help with any questions that you have. And I hope this was helpful.